Okay, we're in section 103. As always, contents, then examples, then exercises. My name is Ron Bannon. This is a draft version of my adaptation of Webster Wells' Advanced Algebra course, which dates back to 1904. This document, the PDF anyway, is being made available to the Prison Mathematics Project participants. I realize there may be instructors and students looking at these videos interested in getting a copy of this. It has not been published yet, but it will be published at a later date. If you're interested, you can reach out to me. My name is Bannon, and my email address is also Bannon. That's B as in boy, the @ symbol, NNON.US. Right? This is section, I want to point out, it's a counting problem. And I got to be honest with you, counting is it sounds easy, but counting is never easy. All right? So they kind of segregated to two different types of counting: a permutation, where order matters, and a combination where order doesn't matter. All right? So, for example, not that I'm going to read the section to you, they talk about permutations of three letters, A, B, C. You know, how many different orderings of that would you have, if you took two at a time? And they write them down for you. And certainly that's something to think about and count it. You can count that up. Now, if you took three at a time, they put that down for you as well. And you can count that up as well. All right? Combinations, a little bit different. You want to get used to that. All right? So I want to point out in combinations, the order A, B, and BA are the same thing. All right? But that's not true for permutations. All right? That's often confusing to a lot of people. But anyway, they give you formulas. I want to point out notationally, the notation I'm using may look a little different than the notation that Wells is using. But I'm trying to, give it a modern feel to it. All right? And factorials popping up again, as we've seen before. This CRN, C stands for combination, P stands for permutation. All right? And they're related to other things that we've dealt with in the past, by the way. So, I know this is confusing. We want to start looking at examples. I point out in my examples, I write down these formulas over here. I do want to point out, I do some variations. The only reason I do that is I notice in other writings, I see this notation nowadays, which to me seems rather odd, but I see it. It has the same meaning. I want to claim, though, same meaning or not, I really got to focus in on how to do the computation. All right? So let's take a look at this thing over here. And there's many ways to do it. Don't think it's only one way to do something. So, like if I'm reading this thing over here, I think I could write it down pretty easily. And it says how many changes can be rung with 10 bells. Bells are used, right, to communicate. So there's 10 bells. I'm going to say, if I thought about it, I'm going to take 7 at a time. So there's really 10 choices for the first one, right? And then there would be 9. Then there'd be 8. Then there'd be 7. I chose 4 bells already. And then 6. And then 5. You get the idea. And then 4, right? Let me count this up for you. That's going to be 1, 2, 3, 4, 5, 6, 7. I chose 7 bells. Do the multiplication. Now, granted, you you're allowed to use calculators. This would give you 604,800. All right, now I'm going to use the other notation. It's going to be this notation over here. And let's write that down. All right, so we're using this notation over here. What's it going to be? 10 factorial over 10 minus 7 factorial. We get the same result, by the way. 10 factorial. 10 minus 7 is 3 factorial. So if you wrote 10 factorial down, when you get 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And if you divide that by 3 factorial is 3 times 2 times 1. What happens? Cancel off. What are we left off with? Exactly what we started with when we just thought about it. All right? That's not bad to think about something. All right, a combination problem. And combinations, we're really not worried about the order of it. So it says how many different combinations can be formed from 16 letters. What does it mean there are 16 letters? All right, now if you wrote this down, I'll just put down, like A1, A2, A3. And these are letters I have. I'm not saying it's an A. I'm saying it's a letter. right? It goes up to 16. Right? There's 16 of these things. And you're going to be taking 12 at a time. And, certainly it's a little more complicated, but, I'll write down the combination now. It's going to be a combination. I use the letter C. There's 16 of them, and we're taking 12 at a time. All right? So let's write down what that would look like. So, I'm taking a choice of 12, so certainly have the 16 letters. So I think it's sort of like an ordering, right? I would do that there. But then you have to start worrying about, when you do that, you have to divide through by all the orders that would be the same. Like, for example, if I have A, B, C, and again, I know that's only 3, that's really the same thing as C, B, A. All right, so I have to divide those away. And that's where that formula is coming from. All right, let's write this down. This is going to be 16 factorial. I'll write this over here. Sorry about that. We're taking 12 of those letters, right? So I got to chop off 4 factorial of them. And what I mean by that is, it's 16, 15, 14, yada, yada, yada. It'll eventually get to 5. Then it'll get to 4, 3, 2, 1. And if you're only taking 12 of them, you're taking this set of numbers over here, by the way. That would give you 12 of them. And certainly what I'm doing, I'm trying to get rid of that part of it. And that's what divided by 4. Now you have to realize with this over here, there's the orderings of that is 12 factorial. Right, so I'll write that down. You've got to get rid of them. Now certainly that's what that formula gives us. And let's put this down now. It's me thinking through it. If I were to write that down, it looks pretty tough though. But the way I would do that, I would do 16, if I wasn't using a calculator, by the way, 15, 14, 13, and then I get to 12. I'm going to say 12 factorial. Let me put the bottom. I do see 12 factorial. I'm going to do the computation for you. And 4 factorial is actually 4, 3, 2, 1. I'm hoping I don't go too fast with that. What do I know? This cancels off. That's good news. Let's see, 4 and 2 is 8. That would give me a 2 here. And let's see, 3 goes into 15, right? 5 times. So what do you get? Again, I'm not using a calculator. You allowed these calculators. You get 10 times 14 times 13. Well, I got to do that arithmetic, right? And I'm hoping I'm getting the same number. Well, 10 times 14 is 140. I got to do 13, right? That's 1,400. 10 times 140 is 1,400. 3 times 140 is 300. 120, that's 420, right? What would that give you? 1820. All right, worked out pretty nice. All right, these, again, it might be a little maddening, but we got to put this down now. How many different words consisting of 4 consonants and 2 vowels can be formed from 8 consonants and 4 vowels? All right, so let's take a look. How many different words consisting of 4 consonants and 2 vowels can be formed from 8? There are 8 consonants. And I'm going to choose from those 8. How many am I going to choose? I'm going to choose 4, right? Let's write this down. This is 8 factorial. I'm choosing them. I'm not talking about their orders. I'm just choosing them. I'm pulling them out. So you're going to get, what? 4 factorial, right? Let's take a look. So it's going to be, I have to do the arithmetic. 8, 7, 6, 5, 4 factorial. On bottom you have a 4 factorial. And another 4 factorial, which is 4, 3, 2, 1. Well, these cancel. I'm just going to see if I can do the arithmetic. 4 times 2 is 8. Got a cancellation there. 3 goes into 6 2 times. So you get 70. Pretty simple. I'm agreeing with that. Well, let's do the other one. And again, we're just choosing these things now. What's the other one going to be? Well, we're going to choose 2 vowels from 4 vowels. 2 from 4. Let's write this down. So it's going to be 4 factorial, 2 factorial, 2 factorial. What do you get there? 4, 3, 2 factorial. On bottom you get 2 factorial, and 2 factorial is 2 times 1. These cancel off. 2 goes into 4 2 times, and 2 times 3 is 6. So what do we got? We have 70 choices from the consonants, and we have 6 choices from the vowels. But how many letters do we have? We have 6 letters, right? Because there's 4 and there's 2. So how many orderings are this going to be? 6 factorial orderings. All right? That multiplication, I don't want to do it, but you can do it. And if you do it, you'll get this number over here. Now, someone says, why don't you want to do it? It's just difficult to do it. But on a calculator, you can actually do 6 factorial times 70 times 6. I also want to point out, calculators also have these symbols over here. They have the P, and generally it looks like this over here in a calculator, P and R, or it might look like C and R. But again, that depends on your calculator. And a calculator can put those numbers, not a problem. They're commonly computed. Let me see if there's any other questions. And there's no other questions. I got to be honest with you, though. This is a tough section to get through. Right? Counting may seem easy to you. Counting is really very difficult. People count things, and they count things incorrectly. Why is that? They misunderstand. But some of these initial problems are basically really simple problems. All right? So, for example, the first one was going to be, looking at it, 14p6. And it doesn't look bad to do. I mean, you could do that. We know how to do that. And if I wrote that down, it'd be 14 factorial. And then 14 minus 6 factorial. Well, 14 factorial. 14 minus 6 is going to be 8 factorial. And again, I'm not saying I'm interested in doing a computation, but please learn how to use a computer or a calculator to do that. All right, so some of these things, the initial ones, they're really straightforward. All right, big computation problem. All right. Oh, by the way, I want to point out 0 factorial is going to be the number 1. There's only one way to order nothing. All right. So let's take a look. More simple computations. They got P's and C's. This is more difficult. It's a reading question. I was just reading through it, trying to make sense out of it. I do put some work down there for you. Number 8, another reading one. I do put some work down there for you. Number 9, I always find these to be interesting questions, but I put the work, at least some work down there for you. Maybe think about it. 10, but again, I'm not saying they're easy. 11, 12, 13, 14, 15. There's a lot of questions. 16, 17, 18, 19. Boy, there's a lot of questions. And again, they're all about counting. One order matters, one order doesn't matter. All about counting. How many ways can you do something? That's the bottom line. All right. Sage code. What is Sage? Computer algebra system. CAS for short. Open source. Go to the website. Give me 1 second. Hey, what can I do for you?
Good morning.
Let me get my mask on, okay? What can I do for you?
I think that I'm in the wrong office.
Okay.
What is the name of the professor that is teaching 119?
I teach 119.
You teach 119?
I do teach 119, yeah.
And 100 too?
I teach 100 as well.
Maybe it's you.
Okay, what do you need?
My son, he's taking 119.
Okay.
But I don't know if that is you are the teacher or not. His
What?
name is Fernando.
My schedule's right in the door. Do you know his schedule? Does he take it like Monday, Wednesday, Friday?
Yes,
Do you know what time he's taking it?
at 8:30.
Okay, so he's in my class then.
Oh,
He's in my class.
okay.
And you have a question?
Yeah.
Sure.
My son, he's autistic,
Okay.
and I asked him because now I have him working in some problems, and he said that he's confused.
Okay. So what I'd recommend is if he has an accommodation, you want to see Maria upstairs.
Yeah. She said that she sent a letter for you.
Oh, she did? Okay,
Yeah,
okay.
and he said that he took a quiz.
What's his last name?
Filian.
Say again?
Filian.
Can you spell it?
Filian. F-I.
Oh, yeah, no, absolutely, yeah. Okay, I know, yeah.
And he tried his best.
I bet he, no, I know, I realize that's the case.
And he said that he was doing the quiz.
Okay.
And he couldn't finish because the time was.
Yeah, what he has to do is, I think what he should do is take it with Maria. So he can do that. So we just have to approach Maria and says, Maria, I want to take the exam. And he can do that. And that way I give Maria the exam.
Oh.
But it's really awkward in class. I can't do that in class.
Oh.
Because then it looks like I'm giving,
Yeah,
you know what I'm saying?
yeah,
It
yeah.
also may make your son feel
And
bad.
how is going to work?
Yeah.